right, application story problem about doubling an investment. So let's say we have $500 at 6.75% interest. It's compounded continuously. How long will it take to double? Well, remember that if it's compounded continuously, here's our formula. P equals E times our rate times T. Remember, the rate has to be in what form, though? Decimal. But here's what we know. 500 is P. That's the R, but make it into a decimal. And so let's plug it in. And we want to find how long it will take to double. Well, what's 500 double? Right there. So what I could do now, first off, you could do, go to the Y equals minus 1,000 plus that 500 and do all that. But let's divide by 1,000 first. Divide by 500, sorry. That'll give this 2 equals this right here. Oh, remember this? How can I get rid of that E? Natural log of E, natural log of 2. So that means that that point right there, 0.0675t, will be that, which is this. Divide that by that, and you get 10.27. Or you could go to your Y equals, type it in like that. You get a graph. Now I didn't put the whole thing in there because all I needed is where it crosses right there. Do that second calculate option 2. Got to be on this side, got to be on that side, enter, enter, and you still get the same answer. All right, here's another story problem. Average salary for public teachers. From 1980 to 2000, the average salary is this formula right here. Basically, that's for 10 to 30 years, where T represents 10, represents 1980. During which year did the school's teachers reach 40,000? So, notice what they're going to do is this. They have changed the thousands to make them into decimals. And we're going to replace the Y with 40. All right? And so, first off, I probably would add this 39.2, divide by this 23.64. So, and how would I get rid of this A? That's a natural log. So do E to that power. That will make this side just an X. So therefore, T will be E to the 3.350 or 28.5 years. Now, is the answer 28.5? No. Actually, if 10, this is a little bit wrong. This is 25.5. It's not added in 1980. I should add 18.5 to 1980 because 10 was already at 1980. So therefore, it would happen in the year 1998. It's almost 1999 because it's 28.5. So it happened about the middle of that year. So what have we learned? How to solve exponential equations using those properties. We've even learned how to do simple ones and quadratics. We've learned how to solve some logarithm functions. Need to get rid of that stuff, get the x's and e's all by themselves. We have to check for extraneous solutions, some that are not possible. And we learned how to solve by graphing. Boy, graphing calculators are really nice. Wish I had those when I was in school. And we learned how to apply some of these in real life story problems. So here's what you are to do. On page 213, problems 17 to 36, 53 to 56, 83 to 90, and 109 and 110. Here are our story problems to work out, and there are some practice at some of the stuff that we need, and I will be happy to help you with those in class. I hope you had a great time watching this and hope it hadn't been too bored.